Hello friends, welcome back. So we were discussing about order by clause. Give me one sec, please. Okay. So yes, Meher, you are right. At the completion of course, will we get some familiar interview question? Yes, I will provide from my end. I will try to provide you from my end. You can use my experience. That is not an issue. So Meher, you are saying order by and sort by difference is that so I have four reducer and data is propagating to four reducer and each reducer will sort it and its task is done. It is sorted. But four reducer will give their output to one another reducer and then it will sort. It's called order by. So everyone sort is not majorly used. Order by is majorly used. So order by is basically launched by a last reducer part. Last reducer which actually collects the output of all reducers. Okay. So coming back to our slides, order by clause, sort by clause, grouping rows, order by and sort by. We are clear. Having clause is something same like SQL. You can use a mathematical operation by average, max, or mean, whatever you want in your query. Join is something very similar to pig or SQL. You have two tables. You can do the inner join, the outer join, the left outer join, the right outer join. Semi joins, matched record you will get, and unmatched records you will get the null. You need to handle that. So I need not to explain you what is left outer join, what is the right outer join, what is the full outer join, what is the left semi outer join. Anybody can tell me what is the semi join, left semi join? So when you get all the records from the left, but get only the matched records of right hand side tables, not the null one. It is a semi join. So when you say the join, how the join actually works, basically you need to understand the two things. It works on the map reducer part. The entire table is partitioning, feed into the mapper. Map is calculate the algorithm based on where clause, and it gives the output to a short and supple and give the reducer. Reducer finally aggregate that onto again the where clause, average, max, mean, whatever, and it will provide the output. Equi-join is not allowed. So you cannot do the kind of query like the same table you can join ID and ID and get the output. This is not join in Hive. So within the one table we used to do this equal equi-join we call that one table is divided into two parts and do the where operation. The not operation is also not performed in the Hive that I told you in the beginning. Yes, Yashwant, half joint. Union all is very similar to our SQL. Two tables I want to combine, merge kind of thing. It is a union. Views, we discussed that we want to extract few column out of one table. It's called my view. I can create the view. This is the command to create the views from my parent table based giving the where clause options. I can drop my view, so it will drop my view, materialized view. It will not drop my parental tables. Partitioning, I just explain you what is partitioning based on the columns. I want to divide the entire thing, data part. So this is the partitioning concept. We can create the partitioning as part of our query. If you see this, you will realize that this syntax, the partitioning based on the date. So Hive will create another metadata based on partitioning. Data is stored in the data node in the same place, but the way of fetching data from the partitioning perspective is now different. This is created for the better optimization, fast access of my data. We discuss this. This is example of partitioning. As I said, from the date wise, it is partitioning. Bucketing, I said you, based on one more nested level, I can partition my partition data into bucketing part. I can my load, if I have created the partitioner and I want to load the data, then I need not to load into my parent data. I can directly load into my partitioned part also. So Hive is also give me this advantage of load the data into my partition part from a certain file name. UDF is something which I can write within or I can write a Hive code into my Java program. Both way it is possible and that can be done by my UDF. Okay. This slide says, can you read this? Map join filter out the extra records while reading the records and it reduce the overhead while doing the actual join, make join fast. Means there is the best practices of Hive also, as we learned in the page. We learned about the map joins, we learned about the replicated joins. There are two joins which we learned in the past. Same thing will apply here. So if you have a right hand table which is small, you can do the join in that part. So each table will generate will available for the each mapper or each reducer whether it is possible. And map join is something which is, are you guys with me or I'm going fast? Am I going very fast? Yes or no? Very fast. Yes. Okay. 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 So we have actually ended up this Hive session. So probably I want you to refer these two joins from my previous session. What is map join and what is replicated join? Okay, and when it is used. Go and see this. If you want more explanation, tell me tomorrow while in hands-on session. I will explain you. There are some limitation in the Hive. This is the time when I can say you what is not possible in the Hive. Since Hive is meant for a bulk operation, one algorithm on the terabyte of data, the DML operation is not possible here, my friend. You cannot say go and update that particular record. No, it is not possible. You cannot say go and insert that particular record into a table. It is also not possible because it is a transactional one. Hive is only suited for the bulk load. You cannot say there is already a table, go and upload this particular record. You cannot delete from, you cannot delete any record from your existing table. Okay. You can only do a bulk delete. That means entire 1 lakh record or 2 lakh record you can delete it again through the MapReduce function because it works from the MapReduce part. It is only suitable for batch. It is not suitable for the batch online real-time processing. Okay. Once you submitted your job, it is very difficult to cancel your theory because the job has already been launched, ID has already been created, task ID has already been created. and execution part is on the way. One thing is that even if you write a smallest query in the Hive, it will take time. If you are using Hive, be very patient and always use for bulk operations. So Satya is saying pig will be more preferred in that case. Not really. I mean, if someone knows a SQL very well, can write a very good query working from past 20 years in SQL, why he will learn pig? He will be more comfortable in the Hive. There are some best practices from the Hive perspective. You need to organize your tables with partition or bucketing kind of thing. You should always be use a proper comment on the table, why this table, from where it is derived, what purpose it is driven. For every field and every line, you should be using the good termination point of thing. One field and two fields are separated with the space, separated with the tab. Two lines are separated with slash and something. Use proper join, whether it is a map join or replicated joins. And if you have a largest table, then I mean, if you have multiple tables and if you want to join that, always keep the largest table which you are using in the topmost right hand side, a largest table on the right side. Okay, so these are the points that we discussed today, and I hope these points which is written here, we should be at least be familiar of how this Hive is developed, what is the purpose of that, what is the benefits of Hive, we all should know, what is the basic architecture of Hive, we should know, what all are the built-in functions, very similar to SQL, how tables are created, same like SQL, what are the joins we used, we should know, and basic concept of UDF, where we will use and what we will use, and concept of bucketing, partitioning, concept of serializer, deserializer, and concept of thrift server. So these are the points which you should be familiar with after this session. So Taranjeet is saying, sir, we will do the practice on lab session high level tomorrow. Tomorrow we will do doing that. So my next question should be, are we good with the Hive concept? Does it look like some familiar? Does we know something about which we didn't know earlier? If we will read, we will go to home and we will read some Hive. Will we be able to understand the concept of all those things? Pulak, Soma, and Taranjeet, I want your comment. How more I can help you? Previous slides. Which previous slides, Rama? Taranjeet, Pulak, I want your comment. How more I can help you? What are the points that you want to discuss more? Which concept is not completely understood? Limitations. You want me to go back to the limitation part? I think we need to more practice. That is true. That is true, my friend. That is true. We need to spend time. I mean, you should have that particular study material in front of you. You will be typing one command, hitting, at least read all the slides in PFPPT. I didn't get Ranjit. Please explain difference between partitioning and bucketing. Okay, Chinmay, I will do that. Please a little bit more on discuss on partitioning, bucketing. Definitely, sure. Any more questions apart from partitioning and bucketing? Best practices, yeah, I will explain you. I will explain you. Probably we can have how to decide what is the bulk delete. So, thing is that if you want to delete the all data which is related to last 10 years, that may be a multiple petabyte of record. That is good. But if you want to record a sub of certain dates, it is not a good idea. That is called a bulk delete. Satya saying architecture. Okay. Okay, so I'm revisiting two topics. First is architecture and second is difference between partitioning and bucketing. Any more question? Any more questions? Is delete a complete delete? Can we retrieve without drop? So as I said, it is based on my external table and internal table. So if you delete something and you want to retrieve it, as a programmer you cannot do, but from the database level, if you are using some database like HBase or Cassandra or something, they have to restore the procedure. I mean, as an admin you can do this, but as a programmer you cannot do this. Is it possible to start Saturday class from 10 a.m. morning because people who stay far from center might become late sometimes and miss the beginning of any topic? So, friend Kuntal, please write this to your center or maybe the Chaya. If you all will be, even I want this by 10 o'clock morning, but it is not in our hand completely. You can understand. There is some recording procedure of this studio. This studio is not always available. We need to stick with the timings. So that may be the reason why people have allocated us this time slot between 9 to 1. Okay. So, Suresh, can we go back to my document? Sorry, I'm feeling a bit cold today. Document. Sorry. Okay, let me go back to. Give me one sec, my friend. Okay. Hey, Suresh, check please. My mic is. Can you hear me, guys? Okay. Okay. So, Hive architecture. Okay. When I say hive, it has two arms. One is metastore and is my data store. Yes or no? Yes or no? I want good. Let's talk about metastore first. This metastore is not a part of Hadoop environment. It is placed somewhere outside the HDFS, maybe Derby or maybe MySQL. Yes or no? Hand raise. No answer. Okay. Derby is discarded. MySQL is into the picture because of two reasons. Because Derby was not giving me facility of centralized access first, and it was not keeping the backup, and it always occupied the place in sorry, the cache. So I replaced this with MySQL. For this MySQL connect, I need a connectivity. What is that connectivity? Is either JDBC or ODBC, which Hive gives the permission to use that to connect my metastore. Okay. Now come to the data store. Data is finally stored into my HDFS. Okay. So when I say HDFS, the theory of data node, name node, job tracker, or task tracker will execute, and we need not to worry about that. These things can be replaced by yarn based on what version of Hadoop you are using. If I am sitting here and I want to access this Hive table, I am using Ruby language. Part of that, I have written a Hive query, and I want to access this particular Hive environment. What all things I need to do? Who will ensure my connections? Who will verify my schema? Who will give me the access? Everything will be done by my script. And this script will sit on another server which is called script server. Yes or no? Am I clear with this point? Am I clear with this point? Yes or no? Okay. Now, if I want to perform a algorithm into this, I need a script. Okay, this script has to be taken care by what I explained you, a parser, compiler, executor. Yes or no? This is what we call as a hive architecture. So if somebody will ask you what is the hive architecture, so you will tell them, boss, there is two component. One is meta store and one is data store. Meta store is something where my schema will reside and which will be maybe the Derby or MySQL, and that will be connected to my hive world. Data store is something where data will store in HDFS, and if my world wants to access that particular data, he has to come through thread server. Internally, the logic execution part will be taken care by all drivers, compiler, optimizer, and executor. And how user can access this? How user can access this? Through either CLI or web based. CLI is something a Linux prompt, and web is something a Hue. What is Hue? Hadoop user environment or experience. It is called a web UI name that is produced by Cloudera or Apache, and now it is available for all users. So this is a complete architecture of Hive. Now can I get all your yes? Anyone has any difficulty in understanding this? Yes or no? Clear. Okay. Thank you very much. Now let's move to partitioning and bucketing. Okay. So let's have an example like this. So I have one table field X, A, B, C, D. The size of this table is 1 petabyte. I want to write a. There is always business requirement like maybe Maggie. Maggie is the hottest project of Nestle. So maybe the business develop engagement manager of Maggie wants every day, every day sales report, every day the turnover report of Maggie. Okay, and this particular thing is stored somewhere like there are various product of Nestle. One is Maggie, second is Cadbury, third one is other chocolate, maybe Melody, but he is interested in this particular field only. So what he will tell his technical guy, boss, I don't care about the entire data. I want only a Maggie record. Create a partitioning with only the Maggie. Give me the date. Give me the sales report. So basically, this is derived from this. This is a one part of main table. This is called a partitioning. You can create your own partitioning from your parent table. You can load your partition table, you can drop your partition table, you can bulk delete the partition table, and you can utilize this partition table as a main table whenever it is required. And if you think how it is managed, so boss, at the end of the day, data is there only. What you are doing, you are just creating a other schema, other meta store into your MySQL or Derby, so that your Hive will understand correctly and it will give a correct instruction to name node and job tracker to collect the data. Otherwise, what it will do, the entire data will split, entire data will go into the mapper, entire data will process, entire data will go into the reducer, and then you will get the output. But now, when you are using your partitioning, basically you are done your data 1 petabyte to maybe 1 terabyte, and your processing is very fast. Am I clear with the partitioning? Yes or no? Okay. Okay. Now, I'm still a business development manager of Maggie. I have the partitioning called Maggie, its date, and its sales reports. Okay. Now, every day my requirement is for each date or maybe the each year I want to generate a graph of sales of Maggie. Okay. So there may be more fields, but from the partitioning table, I want to generate a record. And I'm still finding there are some more there are records which actually I'm not using. I want to further classify it. So this is my main table. I reduce it. Now I'm again going to reduce. So earlier it was 1 petabyte. Now it is 1 terabyte, and now it will be 1 gigabyte. This is my parent table. This is my partitioning, or this is my bucketing maybe. So point is, now my manager is asking me in 2015, give me cells. In 2014, give me cells. Location wise. So what I will do, I will take this date. Okay. So date is something DD MM YY. Okay. I will write a logic to get sorted as per only YY, year wise. That means 14, 15, 16. Now YY is my first field, Maggie product is my second field, and sales is my third field. So if I'm talking about the 14, this is maybe a flavor 1, and sales is XYZ rupees. This is my first record which management want to see. So this is derived from one partitioning. I create a bucketing out of one partitioning, and this is giving me a more nested report in terms of query. Now I can fire my more optimized query, and I can get the more optimized results. Now is it clear about bucketing? Only bucketing. Can I get your yes or no? I'm happy. How do we create? How do we create what command? Hey man, I told you na, man, there was a command to create partitioning, create bucketing with this parent table. So we have all those commands. Don't worry about that part. Just concentrate about focusing conceptual part. Okay. So friends, this is the end of theoretical part of Hive. The next session will be altogether different to this. We will be learning about a very unique thing is called NoSQL. NoSQL. Any idea what is NoSQL? Any idea what is NoSQL? Can I get one or two or three words? What is NoSQL? Not only SQL. Hey man, you must be googling. Opposite to SQL. Okay. Can I get a better answer? Not a relational database. Oh, that is a better answer. Chinmay. Some more understanding about that. Not only SQL. Yeah, that is a traditional definition. Not only a SQL. Okay, so we are jumping from Hive to NoSQL. So there must be one break, right? So let's meet. Okay, let me tell you. NoSQL is divided into two parts. Okay, NoSQL is divided into two parts, one and two. Today I am going to describe you the first part. The purpose of that first part is to give you brief understanding about how data is actually stored and what is difference between SQL and NoSQL things. There will be nothing much that you don't know because most of the time I will be explaining about the RDBMS and the SQL which you already know. And slightly I will change my track towards the non-SQL part of that and I will be comparing that. I will try to compare a one traditional one that is HBase. I will try to explain you how the data will transform from SQL to NoSQL and then I will stop my session and in the second session I will tell you how to deal with this, how to deal with NoSQL. Okay, so before that we jump into NoSQL part. Give me a 5 minute of break. I will recollect all the relevant slides and I will come back to you. Okay. So Suraj, can we take a 5-10 minutes of break? 10 minutes of break. Okay, 10 minutes. Okay, friends. Before moving further, just a minute. There is one question. Before moving further, could you please tell the difference between pig and hive? When to use each one of them? When to use? The very weird answer is if you know SQL, go to hive. If you don't know SQL, go to pig. No other difference. Did I answer your question, Pulak? Okay. Is 10 minutes break is okay? Yes or no? Or you want to 5 minutes? Somebody has told me he didn't get time to have a tea. Let's meet after 10 minutes, okay? Okay. Yes, Suresh, please. Hello friends, welcome back. I hope you got enough time to have your tea. So I can see one question from Hitesh. So we can discuss after session and you can talk with an IT technical person and guide them for next step. Might be I missed something. My contact number is. I didn't get Hitesh. You're talking about Hadoop installation? Okay. 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 Right today I don't think it is possible because I'm not near to my laptop or computer, but how I can help you. uh, okay, fine. I got your number, so uh, let me see how can I help you. So wherever Hadoop is not installed, please ping up your NIT guys, center guys, so that you can get all those things. And any help required from my end, I'm available. No issue. Okay. So Suresh, can you go back to our document and let's start a brief discussion about the NoSQL part? Okay. Thank you. You guys can see my. It is available. Remy, I think it is available. Just check with your center. It is available now. Okay. Okay. So if you can see my document, this pad. So probably as I said, today we will be covering our first part. That is, we will be more discussion about. We will comparing our RDBMS and non-RDBMS. This is SQL and this is NoSQL. Sorry. So you all are very smart to understand that this is not only SQL. That means SQL is there, but also something is there which is not SQL, right? So they should be more efficient. Okay. So thing is that I'm sorry. Before I start, we should also understand that why SQL comes into the picture, why RDBMS comes into the picture. Because in 17 or 80s, uh, transactional word was established. Okay, what is transitional? The banking and healthcare and all those things. So where we required actually a row and column based database, where I want to update, insert or delete a one particular record of one particular user. So I have a 10,000 record. I want to change only one record and rest all records should be unchanged. This is called a transactional one. Okay. So this was possible in 80s and 90s because we were dealing with a very low number of data. Data was not a very challenge. So existing technology of RDBMS and MySQL and Oracle was good enough to give this capability. But when this big data revolution happened, the new business requirements came like analysis, prediction, reporting, recommendation, and all those things, where bulk processing was required. This RDBMS got failed, right? What was the consequences of that? I mean, why we think about that RDBMS is not going to help us? But we should also not forget about that. Every database has some parameter which we need to consider whether it is good or bad. Okay, what all those parameters? Can anybody tell me what is cap and what is acid? What these two terms stands for? Anybody can tell me? Can anyone tell me what is acid property? No? Atomicity, good. A as in atomicity, that is true. C as in consistency. Very fast. I as in integrity, maybe isolity. Okay. And D as in durability. D as in durability. Okay, fine. So point is, if I'm considering a good database, it should have these properties. So when I said atomicity, that means if I'm updating one record, it should complete. It should complete all or it should not complete at all. There is only one operation, that is 0 or 1. There is no intermediate stop. Okay? Either it is done or it is not at all done. That is the atomicity. Consistency is something where it goes from one state to other state. It should not land in between. Okay? That means if I am on insert stage, it is completely go into the normal state. It does not lie between some between. It is partially insert or partially delete or partially state, and we need to reset it. It should not happen in any case. Okay, and isolated means if I am doing that kind of data that is a log, I should not be able to do this. Okay, and durability is something my record should be stay there until and unless, I mean, it should not be get disturbed without any algorithm or any process which is not required. Means reliability kind of thing. So for any database, these are the properties which we required. And SQL was a very best on this. When SQL was developed, these properties are completely fulfilled. SQL has written a new history. It was a impression that SQL is something which we were doing and it will never be replaced because it's giving me the some basic uh, operation like DML, data manipulation. I can insert, I can delete data. DDL, that is data definition. I can create table, I can select table, I can drop table, I can create the view. So I can define my data, all those things. Transactional, I can update that, I can insert that on the very one record also. Okay, and abstraction from physical layer, I can create the views and triggers or something. So I told I will be talking much about the SQL when we are studying about the SQL because we need to understand what all are the properties that over dominated by NoSQL when already SQL was presenting a very good role. So one of the best beauty of the SQL was that a key part. You can create n number of keys. You can create a primary key. You can create a secondary, maybe tertiary, maybe composite key also. So you can create a key, fire a query, and you can get the result. Okay, but again, the bottom line is that you are processing a small data. Everything is possible. You are doing n number of good property, but you are doing this with your small number of records. So problem with big data is that they are not completely occupied with this good feature when they try to come up with this new things. And who all are the master of SQL database was? You must be aware that Oracle, IBM, I'm sorry, IBM DB2, MySQL. Anything else you can guys think of? Any one RDBMS data with server? Sybase, okay, that's true. Now, it's time to see the MySQL, NoSQL term. So believe me, RDBMS is no use for Facebook, Flipkart, Amazon, Twitter, Google, because they always want to work on big amount of data. Okay, so let's understand a NoSQL concept. So point is, we have a very relational database table that is called name. I think you take it. Last name, address, role, location. Okay. So I'm writing two records. First is name is N1, record is L1, address is A1, role is R1, and location is LO1. Right? As per RDBMS. Second record is N2, L2, A2, R2, LO2. This is my row. This is my row. This is one row. This is second row. And this is my field. Say column. Column 1, column 2, column 3, column 4, column. I'm not happy with this structure. Okay. Now I want to change it. How I'm going to change it? What I will write, this is my column. I will make a column structure. This is my row structure. How I'm going to find my column structure? I will take this N1. Okay. And I will write down here 0, 1. What I will do, I will write here N2. I will write here 0, 2. I will write here L1. I will write 0, 1. I will write L2, 0, 2. A1, 0, 1. A2, R1, 0, 1. R2, similarly LO1, 0, 1. LO2, 0. Now I have 1, 2, 3, 4, 5 records. Earlier I had only 2 records. What I did, I convert column into the row. So first I need to ask you, are you getting what I'm saying right now? Are you clear with this example? Okay, that's good. So, if you're okay with this example, then you can see here I am writing 0, 1, 0, 1, 0, 1, 0, 1, Here I am writing 02, 02. This basically shows first record, maybe in our term, N2 maybe the second record, L1 maybe the first record, L2 maybe the second record. Okay. So I converted my entire row into the column format. Is it the only way I need to do this? Yes. Conceptually, it is the only thing what I am doing to converting row into the column part. Okay. So what if I want to get the record of name 1? I need to fetch this, right? If I want to fetch the record of N2, then I have to find out this. So possibly, if I want to fetch only one record, I need to focus on 01th record. And if I want to focus in 02 second record, I need to focus on 02 record. So this is a symbol. This is a key which is giving me heads up that this is the first record and this is the second record. Okay. Apart from that, if some point of time my role gets changed, then I need to change this particular column, right? Now my role is changed from maybe developer to lead developer. So if it is a RDBMS, I will go and cut paste that, right? I will cut the previous programmer position, developer position, and I will write a new one and previous will be lost. But here, this role will not cut paste kind of thing. It will update. How it will update? A new version of record will be written here, where R1 will be the same, but R2 will be version 2 will be available. So all versions are always present. So when I say version, then always it will come with the timestamp kind of thing. Each record has a timestamp. So when you are fetching a record, then probably you are using a timestamp. So this particular time, give me the all record. This particular thing, give me the all second record of this particular time. What benefit we are getting? We can process a mass amount of data in this way. I know the always name is going to be the same, last name is going to the same, address is going to the same, only role is going to the change. So I will pick only the row column and I will take the timestamp of that. I mean I'm filtering it in a better way. Now I'm selecting only the row part. I am selecting on that particular timestamp and I am selecting into the particular operation. So you may find, I mean, this is a bit tricky and new things, NoSQL kind of thing. But my today's agenda was to give you the heads up of how this NoSQL will be look like. So don't get confused. We will again going to take this into the next session also. Point is, you should remember that this is not only a one technique of NoSQL database. If I am telling you NoSQL database, then row into column is not only a one way. There is a 4 or 5 type of NoSQL database. Okay. First is column. Second is document. Third one is graph. And anyone know anyone else type of data? pie chart, image is document, key value pair. So I am keeping you here with this note that we have a four kind of NoSQL database. First is column, which I just give you little bit heads up. Second one is document. Each record will be document. Graph is something where we will capturing our graph thing, and key value pair is every record is against one key information. So I'm ending this session here because I'm not feeling well actually. I'm just wrapping up this session 30 minutes before. In the next session probably I will explain you the complete all things. So here in this NoSQL database, only the column row to column is in our scope. I will be explaining you H-based database that is primarily based on row to column. Rest we will discuss about what is this and how this works actually. Okay. So I'm sorry about that. I'm just wrapping up this session with a small note of NoSQL database. I hope at least you get a hint of what we are talking about. In the next session, I will be covering this topic again, and I will take you through this entire topic of NoSQL database. But I hope you are clear with the Hive thing first, and second, introductory part of NoSQL database. Yes or no? Tomorrow 11 to 1, right? Right. Okay. Okay. So thank you very much, and I'm sorry for that. Okay. I'm writing a one query. Probably this is going to benefit for you. Uh, just hang on for 1 second. It is related to your courseware. There is one question. Please respond. It is for you. Whether you got your digital ware or not. Okay, my friend. Thank you very much for your input. I'm wrapping up this session. Tomorrow we will see at 11 o'clock, and no sequel. We will be taking again the next Saturday. Okay. So till then, goodbye. Take care. Bye bye.